Hi, so for today, we are going to talk about solving logarithmic functions. And for today's video, we're going to solve some logarithmic functions, the solution to a logarithmic functions. And for today, we are just first going to discuss some properties of logarithmic functions or logarithm. So the first one, we have logarithm of x, y, meaning variables x and y multiplied with a base a. We can simplify it as a sum of the individual logarithm of x and y with the same base. So we have log of x with base a plus log of a with base a. Okay. If it is in multiplication, again in logarithm, it can be simplified as the sum with given same base. So for number 2, we have logarithm of x all over y. So we have a logarithm, okay, that is x all over y having a numerator and denominator with the same base a. So we can have it simplified as the logarithm of x with base a minus logarithm of y with base a. So again, whatever is the numerator, that comes first in our logarithm. So for example, if we have a logarithm of y all over x with base a, so it will interchange. So you have logarithm of y with base a minus logarithm of x with base a. Okay, so number 3, logarithm, we have logarithm of x raised to p, where p is any constant, okay, raised to a power, raised to a certain exponent p, okay, with base a. We can rewrite it as log p multiplied by the log of x with base a. So simply, what we did is that we just put this in front, okay, and multiply it to the whole logarithm. So to see that example, let's take a look at this. So we have log of x raised to 10 with base 2. So we can rewrite it as 10 being the letter p here, or the variable p here, raised for a certain power. So we have 10 log of x with base 2. Okay, so that's how simple it is. And last property that we are going to use here is that if logarithm of x with base a equals logarithm of y with base a, then it becomes x equals y. So what happens is, it turns out, if we have a two logarithm on the both side of the equation with the same base, it turns out that it is as if it's canceled. And then we are left with only the x and y. So here are some useful properties that we can use in solving logarithmic functions. Okay. So let's try to solve some in order for us to understand this. So solve the following. Okay. So for number 1, we have 7 raised to 3x, okay, equals 5. Okay. So the very first thing that we're going to do here, we know that this is an exponential. But we know that exponential can be converted back into logarithm, okay, if we cannot express both sides of the equation by the same base, which is in this case, we cannot, because where can we raise 7? Okay, that it could be equal to the same base on the other side, 5. So there's nothing. So what we can do is to take the logarithm of both sides. Okay, so logarithm of 7 raised to 3x equals the logarithm of 5. So if I did not take any base here, it means that it has the base 10 automatic. If you see a logarithm without a base, it's automatic that it is in terms of base 10. Okay, so using the properties, as you can see, this is an exponent. So we can, we can rewrite this as, we can have this as 3x multiplied by log of 7, okay, equals log of 5. So we are now therefore able to isolate the value of x. So x will become now logarithm of 5 all over 3 logarithm of 7. So if you're going to evaluate that in your calculator, it's approximately equal to 0.2757. Or if you're not allowed to use your calculator, this can be an accepted answer. Okay, so that's our problem number 1. For problem number 2, okay, we have 2 minus 10 raised to x equals negative 28. Okay, so the very first thing we're going to do here, on the left side, we have a constant 2. So as much as possible, we want to eliminate that. So what I'm going to do is to transpose that to here. So I have negative 28 minus 2, that becomes negative 30, and I have negative 10 raised to x here. So I want, as much as possible, both sides of the equation to be positive. So I'm going to multiply it both sides by negative 1. There's no harm in doing that. So we have 10 raised to x equals 30. Okay. Again, 10 and 30 don't have the same common base. We cannot reduce it in the same common base. So our option here is to put log, okay, on both sides of the equation so that this becomes this. Okay. So, or this becomes 10 raised to x equals log of 30. So what are we going to do here? So again, exponent property. So you have x log x multiplied by the log of 10 equals log of 30. So multiplying or isolating x, we have log of 30 all over log of 10. Okay, so in that way we have 1.4771. That is our answer for number 2. All right, so pretty much easy. No? If we know the properties of logarithm, it's very much easy to solve these types of problem. Okay, so for number 3, let us try. Okay, for number 3, we have 5 times 0.3 times raised to x minus 2 equals 30. So the thing here is that, again, as much as possible, we want the exponential function or the logarithmic function only accompanied by itself, okay, having no constant. So I have to divide this both sides by 5 so that this 5 will be eliminated and will be left over on the right side of the equation. So we have 30 all over 5, that's 6. So that is 6. And what happens is we take the logarithm of both sides, since we cannot express them into the same base as what we have discussed in exponential function. So same property. So we have x minus 2 here multiplied by the log of 0.3 equals log of 6. Okay. First things first, divide both sides by log of 0.3. So I have log of 0.3 here. Transpose negative 2 on the other side. That becomes log of 6 all over log of 0.3 plus 2. Okay. Evaluating, this will give you 0.5118. Okay. So far we have used the property of the what do you call this? The property of exponential or exponent. Okay. So right now we're going to use the product rule and as well as the quotient rule if we can apply it. Okay. And by the way, we can also apply this to natural logarithm. Okay. So the same properties for the natural logarithm that we have, the ln that we have. So I have here an example of log of x plus 1 plus log of x minus 1 equals log of 8. So I have log of 8 here. Okay, so first things first, we know that this is the same base, and we have plus. So we're going to use what? The product rule. Okay, so we have log of x plus 1, x minus 1 equals log of 8. Okay, so after that, what can we observe from this? Okay, so from what we can observe, we have log here equals the same log with the same base 10. So therefore, we can have it canceled it out. It's as if it's been canceled because of the property we have discussed here at property number 4. Okay, so we have now x plus 1 times x minus 1 equals 8. So if I'm going to FOIL this, that would be x squared minus 1 equals 8. So x squared, we have 8 plus 1. We have quadratic here. X squared equals 9. Take the squares of both sides. We have x equals positive or negative 3. Okay? So we have two answers because of the square root. But in terms of logarithm, okay? In terms of logarithm, it is always, okay, safe to assume that the negative value that we have here would not be acceptable. Okay? The reason why, if you input into your calculator the logarithm of negative value, any negative value, it will be an unidentified. So this will not be considered as answer. Only the positive value. Okay? So because if you try to substitute x equals negative 3 here in the log of x plus 1 plus log of x minus 1. So we have negative 3 plus 1, that's negative 2. Log of negative 2 is math error. It's undefined. Okay? So the inside function of the logarithm should not be negative because it would make the equation, okay, undefined or math error. Okay, so another example we have here is that we have log of x with base 5 plus log of x minus 3 with base 5 also. Then we have log of 10 with base 5. Okay? So first things first, since this is an addition again, so we are going to apply product rule. So whatever is the inside function, we have x times x minus 3, and then we have log of 5 here with base 5, and then we have log of 10 here with base 5. So as you can see, okay, we have this type of logarithm. And again, this will cancel because they have the same base. So it's as if we have x times x minus 3 equals 10. That we will solve. So we have x squared minus 3x equals 10. So if we try to transpose 10, it becomes negative 10 equals 0. If we try to factor this out, x squared minus 3x minus 10, of course, we will be definitely get two answers for x. And again, take note that if we have a negative x, that will be discarded. Only the positive ones will be accepted as the correct answer. So we have x squared minus 3x minus 10. So what are the two numbers that if we multiply will result to negative 10? And what are the two numbers that if we add will result to negative 3? Okay, so I believe that would be x minus 5 and x plus 2. So x plus 2 and then x minus 5. Okay, so we have two answers for x. One is negative 2 and another one is 5. Therefore, our answer here is 5. And this x equals 2 is discarded. Okay, disregarded or discarded as the answer. Because it cannot, again, logarithm function cannot have a negative inside the logarithmic function because it would result to a math error. Okay, so I hope that's clear. So for number 6, okay, for number 6, we have logarithm of 5 with base 2 plus logarithm of x with base 2 equals logarithm of x plus 20 with base 2. So how does this apply? Again, this is a product rule. So we have logarithm of 5 times x with base 2. Then we have logarithm of x plus 20 with base 2. So the logs will cancel because they have the same base. So this will become 5x equals x plus 20. So we have x minus 5x plus 20 equals 0. And this is very much easy to factor. So we have what? So we have no, it's not going to be factored. Okay. I'm sorry. It's not going to be factored. It's 5x minus x equals 20. Okay. So I overlooked that as an x squared. So no x squared. So definitely we can just transpose the value of x. So 5x minus x, that becomes 4x equals 20. So divided by 4 to get the value of x, that would be x equals 5. So the solution for this logarithmic function is 5. Okay. Yeah. So that's it. That's how we solve a logarithmic function. And of course, if we are going to do it on the ln side, okay, so for example, the natural logarithm. So take note that also in natural logarithm, okay, we still have the same properties. You have ln of a plus ln of b if we have multiplied, and ln of a all over b, that becomes ln of a minus ln of b. So still the same natural logarithm. So if we have ln of e, that means it's equal to 1. Okay, that means that's equal to 1. And if we have ln of a raised to x, so that can be x ln of a. So pretty much the same with the logarithmic functions, okay, for the natural logarithm that we have. So for number 7, if we try to solve, let's say, ln of 2x plus 10 equals to ln of 2. Again, pretty much the same. If another property that we have here, if ln of a equals ln of b, then we have a equals b. So pretty much the same. So let's take a look here. ln of 2x plus 10 equals 2 ln of 2. So what are we going to do here is, of course, take a look at the right side first, because the right side first, we can still what? We can still simplify this. This is 2 multiplied by ln of 2. So we can have this as our exponent, that 2. So in order for us to cancel the ln, so we have ln left side, ln on the right side. So you have 2x plus 10 equals 4, which is raised to 4. Okay, so in order for us to get that, so what will happen is that we're going to have what? 2x 4 minus 10, that is negative 6. So divided by 2, so we have x equals negative 3. Okay? So in terms of ln, okay, in terms of ln, we can have a negative value. Okay? So it turns out that if we try to simplify, or if we try to check, okay, this one, so what will happen? X equals negative 3. So we try to check. We substitute the value of that. That would be ln of 2 raised to negative 3 plus 10. Okay? Then we have 2 ln of 2. So we have ln of negative 6 plus 10. Then we have ln of 2 squared. So that would be ln of 4 equals ln of 4. So it so happened that if we substitute x equals negative 3, the value of the ln inside, okay, still becomes positive. Okay, so that's why we can say that x equals negative 3 is still a valid answer. Okay, so that is for our ln. So another problems for ln, we'll try to solve that involving natural logarithm. I'll check if we still have it. So for number, I think this will be for our last number. So we have 2 ln of x equals ln of 25. Okay, so how do we do this? So that would be ln of x squared. I put this on the exponent, and I have to transpose 25 or transform 25 into 5 squared. Okay, so that cancel. I have x squared, I have 5 squared. So meaning that would be x equals 25. Okay, so x squared equals 25. So you get the square root, I'll be having what? Positive or negative 5. Okay, so in ln, we must check if it is x equals 5 and x is equals to negative 5. We must check if this is valid. If these two are valid. Okay, so for x equals 5, so you have 2 ln of 5 equals ln of 25. So I have ln of 5 squared. I'm supposing this to our exponent. So check. How about if I have ln of x equals negative 5? So we have 2 ln of negative 5. Okay, and then ln of 25. Okay. So, as you can see, okay, if we evaluate this independently, ln of negative 5, that would be a math error. So, our answer only here would be x equals 5, because if we try to ln negative 5, that would be a math error. That would be an undefined. Okay, so our answer here would be x equals 5 only. Okay, so and that's it. And I hope you learned so much from this video about solving logarithmic functions. And if you are new to my channel, please don't forget to subscribe and share it with your engineering friends or with your friends who are in need of improving their skills in engineering mathematics or in just simple mathematics, or who want just to recall about their knowledge about mathematics. Again, see you again on the next video. Thank you and God bless.